Hello team, let's have a look at some of these problems. So this is applied differentiation, okay? So all we're doing is we're taking our differentiation skills and we're applying it to a specific context. But fundamentally, the skills below that is just going to be some geometry and some differentiation. So let's have a look at this first problem. It says, show that the volume is V equals 675x minus 9x cubed over 4. And then it tells us some more about the box. A box is 3x by x by y. The total area is 450 centimeters squared. Use calculus to find the maximum possible volume. Okay, before you do anything else, become an artist and draw a very beautiful diagram, because a good diagram really helps you understand absolutely everything. So I don't know if that's the most beautiful box that you've ever seen in the world, but this can be x, this can be x, this can be y, and suddenly we have an idea of what is happening. Now, generally, in these problems, we're going to have to form two equations that relate to the model. We'll be given little tidbits of information to form those two equations, and we're going to solve those two equations simultaneously to hopefully reach the equation that they give us in the question. So let's have a look. I know the total area is 450 centimeters squared, so I'm going to try and build an equation for that area. So if I look at the box, I've got two faces that will be that will have an area of xy. So that's going to be 2xy plus, then I'm going to have two faces, one at the top and one underneath my box, that will have an area of 3xy. So that would be plus two lots of 3xy. And last but not least, I've got my final two faces. So I've got a face here, and then on the other side that's hidden, on the other side there that's hidden, that will have an area of 3x squared. So that's plus two lots of 3x squared. So that should be 2xy there, just to be consistent. And I know this whole area is 450 centimeters squared. So I think we can make that a little bit neater. So I've got 2xy here, 2xy plus 6xy plus 6x squared equals 450. So I have 678xy plus 6x squared equals 450. Okay, now let's look at the volume. So the volume is just going to be those three lengths multiplied together. So it's going to be 3x multiplies, let's do it like this, 3x multiplies x multiplies y, and that is my volume. Now, what I'm going to do, let's neaten that up a little bit. So I've got volume equals 3x squared y. Is we are going to solve these two equations simultaneously. So I have one equation which is 6x squared plus 8xy equals 450. And I also have volume equals 3x squared y. Now, if I look at my goal equation, I'm trying to show that the volume equals 675x minus 9x cubed over 4. Now, notice there is no y in this equation. There's only x's, which suggests to me that the y is what I'm going to try and solve for and eliminate. So if I have these two equations, I call this equation 1 and this one equation 2. What I'm going to do is I'm going to rearrange equation 1 for y, and I'm going to substitute that into equation 2. So let's take equation 1 and rearrange this for y. So I have 6x squared plus 8xy equals 450. So I have 8xy equals 450 minus 6x squared. I have y equals 450 minus 6x squared divided by 8x. I'm just going to leave it like that for now. What I'm going to do is I'm now going to substitute equation 1 into equation 2. So everywhere where there's a y in equation 2, I'm going to replace that with my new equation for y. So I have volume equals 3x squared multiplies this new equation for y, 450 minus 6x squared over 8x. And hopefully, notice there's no y in this equation now, so we're a lot closer to the goal. Hopefully, if we just multiply through and cancel down and simplify, it should all work out nicely. So let's hope that works. So volume equals 3 times 450. Sorry about this. 3 times 450, 350. So that's 350 x squared minus, that's going to be 18 x4 over 8x. And now the best thing I can do is bring out a factor of 2x. So I've got 2x on the bottom here. 2x multiplies 4. And then on the top, if I take out that factor of 2x, I have 1350 divided by 2. So 1350 divided by 2. 1350 divided by 2 is 675. So that's going to be 675x minus 9x cubed. So then my 2x's cancel. So that's 675x minus 9x cubed over 4, which I think is as required. Cool, so this is as required. Okay, so now we have the fun bit. So we have this expression for volume. So we have volume equals 675x minus 9x cubed over 4. Solve for the maximum or minimum point. So essentially in our original picture here, we're allowing x to vary. So we let this side length here and this length here vary around, get bigger and smaller, and we look at how changing those two lengths affects the total volume of that cube. Now there will be a maximum volume as we allow that to vary, and we can find that by finding the maximum point of a graph of dv over dx. So how does my volume change in relation to x changing? So all we have to do here is we have to just differentiate and set this equal to 0. That shows us that maximum point, that pinnacle of that graph. So I split this up into 675 x over 4 minus 9x cubed. So that becomes 675 over 4 as I differentiate. So that's now dv over dx equals 675 over 4 minus 91827x squared. So I'm setting this differential equal to 0. That means 675 over 4 minus 27x squared equals 0. So I can now just solve this for x. So I have 27x squared equals 675 over 4. I have x squared equals 675 over 4 divided by 27. And then I have x equals, I'm only going to take the positive root as the square root of that answer. So I will have x equals the square root of 675 over 4 divided by 27. So we have square root 675 divided by 4 bracket divided by 27 is 2.5. So x is 2.5. And then we'll check the units. So it was 2.5 centimeters. Okay, so we have this next problem. We have a circular dish, t centimeters high, has a diameter d. The volume is 1000. Prove that the area is all of this nonsense. Find the minimum surface area. So we're going to find the minimum surface area by differentiating this thing right here, setting that differential f dash x equal to 0 and solving for those minimum points. So that's how we're going to minimize this function. But firstly, we need to prove it to start with. So let's draw a picture. So here is a cylinder. Bosh, it goes into the paper there. It's 3D. Okay, we are told that the diameter, bosh, it's like this, d, and we're told the height, t. Okay, so to find this expression, we are going to do our old trick. We're going to find two ways of forming an equation related to this shape, and we're going to set them equal. We're not going to set them equal. We're going to solve both of them and hopefully reach this equation. So we are told that the volume is 1000 centimeters cubed. We need to find the area, so we're going to find equations for both area and volume. Okay, so let's start with area. Okay, so it's got this bottom face here, which will have the area of a circle. So that will be pi r squared. We're not given r, we're just given d. So instead of pi r squared, that's going to be pi d over 2 squared. That's that circle there. And then it has this wraparound area, wraparound surface area, which comes all the way around this way, all the way around that way. And the way we calculate that, that's actually going to be the circumference of a circle times by this height t. So the circumference of a circle is 2 times pi times r, which is d over 2. And then to find this whole circle, the light blue area, we're going to multiply this by t. So pi r squared plus 2 pi r times t equals my area. And we can neaten that up a little bit. We can rewrite that as pi d squared over 4 plus, those 2's are going to cancel, so that's going to be pi dt, just pi dt, I think. There you go. Now we're going to find the volume. So the volume of a cylinder, we take the area of the bottom of that dark blue circle, and we're going to multiply that by the height t. So we are going to go again, we're going to say pi r squared, pi times d over 2 squared, that's the area of the circle, multiplied by t, the height, equals this volume, which we're told is 1,000. Okay, so let's neaten that one up. I can say 1,000 equals pi d squared t over 4. Okay, now here's what we're going to do. I can call this equation 1. I'm going to call this equation 2. And notice in my goal equation, there are no t's. So what I'm going to do is I'm going to rearrange equation 1. So I'm going to rearrange equation 1 to make it t equals. And then I'm going to substitute equation 1 into equation 2, replacing all of these t's, hopefully getting rid of the t terms and landing on this expression for area. So let's start with rearranging this for t. So if I multiply both sides by 4, I have pi d squared t equals 4,000. That means I have t equals 4,000 divided by pi d squared. Now I'm going to replace t in my equation for area with this new equation. So I have area equals pi d squared over 4 plus pi d multiplies, instead of t, 4,000 over pi d squared. That means I have area equals pi d squared over 4 plus cancels, 4,000 over d, and hopefully that is correct. Yeah. So 1/4 pi d squared plus 4,000 over d. So what we're going to do now is we're going to take this and we're going to find, what do we need to find? So the maximum or the minimum. So the maximum or the minimum point. So we're allowing this diameter d to vary, and we're seeing what happens to the area as we allow it to vary. And what does it want? The maximum or the minimum? The minimum surface point. Okay, so I'm going to rewrite this a little bit to help me differentiate it. So I'm going to call this area equals pi over 4 d squared plus 4,000 d to the minus 1. So then I'm going to say dA over d, well, it's dd. That's a bit of a weird one. But the change in area divided over the change in diameter. So if I multiply this, that's pi over 4 times 2. So that's going to be pi over 2 times d plus, that's going to be a minus 4,000 d to the minus 2. So what I'm going to do, I'm now going to add this second term to both sides. So I have pi d, I need more room here. I'm now going to add this second term, I'm now going to add this second term to both sides. So I have pi d over 2 equals 4,000 over d squared. I'm going to multiply both sides by d squared. So I have pi d cubed over 2 equals 4,000. That means I have pi d cubed equals 8,000, which means I have d cubed equals 8,000 over pi. So I have d equals the cube root of 8,000 over pi. Okay, so that is whatever that is. So toolbox, cube root, 8,000 divided by shift pi. Oh, no, don't even need a shift, pi. So 13.7, more or less. 13.7 centimetres, okay, where this is at its smallest point. All right, last one. A closed cylinder has a surface area equal to 600 pi. So this time I've got both the top and the bottom. It's not like an open dish anymore. It's this will be dotty because we can't see it. It's a closed cylindario. Show that the volume of this cylinder is given by blah, 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 where r is the radius of the cylinder. So we're dealing with the radius this time instead of the diameter. So that's the radius. Are we given the height? We are not given the height. And we are given something to do with surface area, and we're asked to find out the volume. So we're going to do our normal trick. We're going to find equations relating to surface area, find equations relating to volume. We're going to put them together, lickety-split, see if we can get to this equation here. So firstly, let's think about area. I have this face and this face this time. So let's start with that. So that's pi r squared. That's the area of one of those faces. And then I have two of them. So that's 2 pi r squared. And then we have all of this wraparound area like this. So that is going to be the circumference of that circle. So that's 2 pi r times by, I'm just going to make up a variable. They didn't actually give us this h, but I'm going to call that h, times by that height. So 2 pi r is the circumference times by height. That'll give me that light blue wraparound. And I've got two pi r's. Okay, so that is area. Okay. Now, volume is going to be the area of one of those cylinders, one of those circular faces at the base and at the top. So that's going to be pi r squared, and that's going to be multiplying h, the height, and that will be my volume. Now, I'm also told that area equals 600 pi. Now, I want an expression for volume. Obviously, there's no h in this expression because we invented that h to make our diagram work. So what I'm going to do is, if I label this equation 1, this equation 2, I'm going to rearrange equation 1 to make it h equals blah, blah, blah. And I'm going to substitute equation 1 into equation 2, eliminating h, and hopefully we will reach this equation here. So let us rearrange equation 1 for h. So where can I go where I've got lots of room? Oh, let's go here. So I've got 2 pi r squared plus 2 pi r h equals 600 pi. And let's begin rearranging this for h. So I have 2 pi r h equals 600 pi minus 2 pi r squared. So I have h equals 600 pi minus 2 pi r squared divided by 2 pi r. I can do some cancelling, but I'm not going to bother just yet. I'm going to substitute that straight into the volume equation. So my volume equation, I now have, instead of pi r squared h, I have pi r squared multiplies 600 pi minus 2 pi r squared divided by 2 pi r. Okay, here we go. So hopefully if we just do a bit of cancelling here, this should come to our required equation. So I've got a pi cancelling, an r cancelling, and r cancelling. So I have r multiplies 600 pi minus 2 pi r squared over 2. So I have volume, if I multiply that r through, equals 600 pi r minus 2 pi r cubed over 2. Divide both of those different parts of that numerator, volume, V-O-L-U-M-E, I'm a dyslexic, equals 600, volume equals 300 pi r minus pi r cubed. Now, we've crossed our fingers and we hope that's as required. 300 pi r minus pi r cubed. Hooray, we did it. Okay, now it wants us to find the maximum volume of this cylinder. So what we're going to do, we're going to take this, we did it. We're going to find the change in volume over the change in r. Now, the maximum will occur when this differential equals 0. So firstly, let's find this differential. So I times 300 by, there's a little power 1 here on this r, so 300 pi times 1 is just 300 pi. The r1 becomes r0, which is 1, so we get nothing, so that's going to be minus 3 pi r squared. And the maximum point occurs when this equals 0. So I have 3 pi r squared equals 300 pi. So I have r squared equals 300 pi divided by 3 pi. So r squared equals 100, r equals 10. I'm only taking the positive square root here, positive root, because obviously you can't have a negative radius. That doesn't make sense unless you've inverted space-time. So yeah, hopefully that helps.